In this video, we will learn about the basics of Scilab. First, we should know what is Scilab. Scilab is a freely distributed open source scientific software. It is numerical oriented programming language. The Scilab can be used for signal processing, statistical analysis, image enhancement, fluid dynamics simulations, numerical operations, etc. So let's start. We will learn basic calculations, addition, subtraction, multiplication, division, square root, square, cube, nth root, nth power, etc. Variables and string, user defined function and for loop, plotting a graph in Scilab, polar graph in Scilab, definite integration, matrix operations. So let's start. Open the Scilab 6.1.0. This is the version. It is freely downloadable from the website scilab.org. We can see there are 5 windows here: file browser, variable browser, command history, news feed, and the console window. All values of the variables will be shown here in the variable browser. Newsfeed shows the latest all information or news by the Scilab website. If we have internet connection, we can see the command history, all command histories from here. This is the console window, which is the main window where we will type all the commands. Here, this is the synods, which is really important. This is synods window. We can save our program in synods, and the extension of these synods is .sce. Okay. Minimize it. This is brush tool. This is also important. To clear the console window, we can increase or decrease the size of the fonts from edit menu, preferences, and you can adjust the font size and its style also. Here console window and synods. So here we can do all the simple arithmetic operations. As the example, 15 plus 20. We will get the answer is equal to 35. A and S is auto-generated variable, inbuilt variable, and we can see the answer here 35. Its type double, visibility local, memory 216 bytes. This is the command history. Another example, 12 minus 6, answer is equal to 6. Now the A and S variable will be changed here, 6. Okay, 12 into 45, 89 divided by 12, answer is equal to 7.416667, like that. 5 raised to 2 is equal to 25. We can use double asterisk sign instead of the caret sign. 5 asterisk 2 is equal to, we will get the same answer 25. We can store the variables as the example A is equal to 33. Now to clear the console window, we can use the brush tool or type simply CLC, clear the console window, enter. A is equal to 33. So here we can see the variable A is equal to 33. Its value is shown here. Okay. You directly put the commands from here, command history. Just double click on it and we will get the command. Okay. You can use from here or you can use up or down arrow key from the keyboard. Okay. Now all simple operations are possible for the variables. A is equal to 33, B is equal to 55, and summation of A plus B, we will get the answer 88. A minus B, A into B, A divided by B. Also forward slash we can use A forward slash B. This is like a inverse into B, B divided by A. This is all simple arithmetic operations. We can calculate the square of any number using SQRT function. Okay, this is inbuilt function. As an example, SQRT, square root of 25, we will get the answer 5. Okay, SQRT, square root of 169, we will get the answer 13. Now we can also calculate nth root of any number using inbuilt function nth root. Nth root of 25 comma second root, we will get the answer 5. Another example, nth root of 36 comma fifth root of the 36, we will get the answer is equal to this. Okay. Scilab can generate random numbers also. To generate the random numbers, RAND, use RAND command. We will get the random number. Again, you can use random and we will get the another number. This is changed. Okay, these are not same. To see the value of any variables using the inbuilt command display, disp of A. Here we can see A is equal to 33. Display of A is also shown the value of A. Display of A is 33. Any string is written in the double or single inverted comma, but generally we should use double inverted comma. Let's take an example. Single inverted comma, hello. So we will get the answer is equal to hello. Double inverted comma, hello. Okay, we will get the same answer, same string. Suppose A is equal to some string department of space. B is equal to physics, the physics. And we can summation of the A string and the B string, A plus B, we will get the answer department of the physics. Okay. Now, to know the length of the string, we use length command, inbuilt length command, length of A. Here A is this string, department of 14 character are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. It counts the space also. Simply here we can create loop also. As an example, y is equal to 0 colon 1 colon 10. Here 0 is the initial value, this is the interval between two values, and this is the final value. Okay, initial value, interval value, and this is the final value. Enter, we will get the answer of y. Y is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. For decrement, we can use y is equal to from 10 to 0, 10 colon minus 1 colon 0. We will get the y is equal to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, this is the decrement. We can also use the another command which is called linspace, linspace, linspace. Suppose A is equal to linspace of 1, 1, 100. From 1 to the 100 values, here interval like 2, from 1 to 100 values in the interval of 2. Okay, enter, we will get the answer A is equal to in interval 2, 0.02, 1.01, 1.02, 1.03 and so on. The 100 values are there. This is the parts, total parts of the variable, total 100 parts here. Okay, and this is in 0.02. Now we will learn to create user defined function, our own function. First, open the sign out window. Here some example here. Suppose sum of arithmetic sequence. Okay, series summation. Function, user defined function. We can use function, and here the user defined function name of the function, any name we can write here, like suppose s1 of x function, c is equal to 0. This is some initial value. Here we can use for loop. I is equal to 0 in increment 1 up to x value. C is equal to c plus I. For loop and display of value c, final value of c. We can execute it from here, save and execute all. On the desktop we can save the file series.sce, save. So it is executed. Now s1 of some value 5 and we will get the answer 15, the summation of the series summation. This is the user defined function which we created. Now execute the another user defined function I have created earlier. Yes, factorial. So this is the function factorial of any number. Function name is factorial fact, F-A-C-T, of x. X will be any number. C is equal to 1 initial value. For I is equal to initial value 1 interval 1 up to x value. C is equal to c into I, for loop and display of c. Execute it and we will get the answer fact of 5. We will get the answer 120. The factorial 1 into 2 into 3 into 4 into 5. The factorial of 5 is 120. But instead of this user defined function, we can use the inbuilt command to evaluate it. It is the factorial of any number 5. We will get the same answer. Okay, factorial 10. Okay, very simple. Now another thing to know, we should know the another thing. Here we can show the all commands here by press Ctrl plus E. Okay, we can see the all commands here, and now we can use the function fact of 41. This is the answer. Now we are going to plot the graph using the Scilab. There is a plot command, plot P-L-O-T command to do it. This is very simple. Let's check it out. Suppose y is equal to x is equal to 0. Increment 0.1 up to 90. These are the values of x. Y is equal to sine of x. This is the data of y. y is equal to sine of x. Okay, now plot the graph plot the graph of sine function x comma y versus x. We type here x comma y. Okay, enter, and we will get the graphical window will be shown the graph of the sine function. We can see here, this is the sine function, this is the x-axis, this is the y-axis. We can label it also. Right click, label x. We can write here something angle, label y sine of x. We can make a title, sine function. Now we can increase the font size also. Edit, axis properties, here x-axis, y-axis, title, z-axis also. This is the font size. Increase the font size, y, increase, title, increase. Okay, so this is the graph, our graph of the sine function, sine of x. You can take any function like y is equal to x square plus 2x minus 3x cube, any you will get the graph. Now for the polar graph, we are taking the example of radiation pattern. I have created a sine knot for it. Let's open it. Open the sine knot. Here polar graph. Okay, yeah, radiation pattern of the dipole antenna. We know angles are taken in radian. Scilab works in radian, so we convert it into degree. So x is equal to 0 degree in interval 5 degree, 5 into percentage pi divided by 180. Here percentage pi is the inbuilt value for pi. Pi is equal to 3.141592 ... and this is my data, which is noted down in our physics lab. Radiation pattern data of the dipole antenna. This is the final value, 360 degree, up to 360 degree. Scilab to clear previous figure or frame. Okay, it will erase the previous all graphs, figure or image, previous figure or frame. Polar plot is the command to plot the polar graph, which we can see here, polar plot, POLAR, polar plot of x comma y versus x. Here 64 is just added to reduce the scale of the y-axis. for the better graph, better performance, and we can see the perfect dipole radiation antenna pattern. Execute it. See, this is the pattern of the polar graph, in the polar graph of the dipole antenna radiation. Okay. Now let's go to the next, definite integration, definite integrals. Okay, I have to define a function for it. So open the psi knot and write down function, some function I is equal to f of x, I is equal to x square plus x plus 2x or any minus 5. You can take any function, enter, and function. Okay, some initial value a is equal to 0 to final value b is equal to 5. Suppose 5, enter, in integer I take the variable in1 is equal to int. This is the inbuilt function, inbuilt command for the integration a comma b comma f. Display of the answer, integration 1. The answer of the integration will be stored in some variable in1. Okay, we will get the answer of the integration of this function. Int is the inbuilt function for integration, f is the function, I is equal to x square plus 2x minus x with respect to x integration. This is the initial value a, this is the final value b. Now execute it. Control plus E. We will get the answer 41.666 something. Okay, this is the answer. You can check it. X cube by 3 plus 2 into x square by 2 minus 5x. Okay, and take limit. Now we can change here. We can scan the value of a and b. Input of initial value, b is equal to input of final value. Execute it. Control plus E. Here we can see, I have to save the file, desktop intg, save. So initial value a is equal to 0, b is equal to 5. You will get the same answer, 0. Execute again. Initial value 2, final value 6, we will get the answer. Okay, we will get the answer of the integration. Instead of the user defined function, we can use the inbuilt another function, another command, which is integrate. INTGRATE, integrate command. Type simply integrate of single inverted comma. Here we will write the function x cube plus 2 into sine of x, 2 into sine of x minus 6, something like that, comma, single inverted comma, with respect to x, initial value 0 to final value 10. Enter. We will get the answer is equal to 2443.6781. This is the answer. You can check it. Okay. This is the perfect answer. It gives the perfect final answer. Okay. Now we are going to learn about matrix operations. Very important. Matrix can be expressed as table which has m rows and n columns. It is like a 2D arrays, two-dimensional arrays. How we can express it? Let me take an example. Suppose A is equal to, in square bracket, 1 space 2 semicolon 3 space 4 bracket complete. Here rows are separated by semicolon. This is the first row and semicolon, this is the second row. Okay, and the columns are separated by the space or single comma sign. Enter. We will get the answer. A is equal to 1 2 3 4. This is the matrix A. A is equal to, we can also use the comma sign, 1 comma 2 semicolon 3 comma 4 bracket complete. Okay, for matrix we should use the square bracket here. Sum B is equal to 3 space 4 semicolon 8 15. So we will get the answer B is equal to 3 4 8 15. Okay, now some commands which are used for matrix. So what's the command? I will show you in the notepad. Sum A prime product mean value, minimum value, maximum value, mean value, size of the matrix, length of the matrix. Okay, this is the all commands. Also zeros of 3 by 3 2 by 2 matrix, any matrix, 4 by 2 2 by 4. Okay, ones for the ones, unit matrix, 1 the 0th matrix, I is for the identity matrix, and it generates the random matrix using the rand command. Okay, summation of the all elements, type here A prime. This is the transpose of any matrix A, diagonal matrix, product of the elements, mean value, maximum value, minimum values. This is the minimum value, this is the mean value, average value, size of the matrix, this is the length of the matrix, zeros, ones, identity matrix. It's of all of diagonal elements are 0 and only diagonal elements are 1. This is for random matrix. Okay, let's check it out. A 1 2 3 4. Here we can change the elements from here. Double click on it. 1 2 3 4. This is the variable editor, variable data sheet. Close it. Okay, A is equal to 1 2 3 4. Sum of A, you will get the answer 10. Summation of all the elements 1 plus 2 plus 3 plus 4, we will get the answer. Sum of A comma R, we will get the answer 4 and here 6. This is the row matrix and the summation of the column matrix. 3 plus 1 4, 4 plus 2 6. This is the row matrix for this for the row matrix, and we will get the answer of the summation of the column matrix. Okay, product of A, answer is equal to 24. 1 into 2 into 3 into 4. Product of A comma, we can also use C for the column matrix, and it calculate the multiplication in row. 2 into 1 2, 3 into 4, we will get the answer 12. Okay, product diagonal element of the A, 1 and 4. 1 and 4. Clear the console window. CLC diagonal element A inverse A prime for the transpose 1 3 2 4. A is equal to 1 2 3 4 and A transpose is 1 3 2 4. Minimum value of the A matrix is 1. Maximum value of the A matrix 4. Mean value of the matrix will be 2.5. Size of the matrix, we will get the 2 and 2 cross 2 matrix. This is the size 2 cross 2. Length of the matrix 4. There are the 4 elements are there. Okay, now zeros of 3 by 3. Suppose 3 by 3 matrix. ZEROS 3 comma 3. You will get the answer 0 0 0 0 0 3 by 3 matrix. Okay, once for the unit matrix 1 1 1 1 1 3 comma 3, you will get the answer is equal to 1 1 1 1 1 3 by 3 matrix. Okay, now identity matrix I of 4 comma 2 is the identity matrix. Diagonal elements are 1 and off diagonal elements are 0. Okay, identity matrix I of 3 comma 3, suppose 3 comma 3, you will get the answer 1 0 0 0 1 0 0 0 1. Now we can do arithmetic operations for the matrices. I have to take two matrices. Suppose A is equal to 2 2 4 comma 5 6, B is equal to suppose 5 8 comma 7 10, and we will get the both matrix A is equal to this and B is equal to this. We can do all arithmetic operations for these two matrices. Before that, random matrix, it generates the random matrix using RAND command. Random matrix of 3 by 3 matrix, you will get the answer. This is random matrix. Again, you can use it and check it. The numbers will be changed, answer will be changed. Okay, now A B A arithmetic operation A plus B. This is the method element by element. 2 plus 5 7, 6 plus 8 12, 5 plus 7 12, 6 plus 10 16. Very simple. Also A minus B, 2 minus 5 minus 3, 4 minus 8 minus 4, 5 minus 7 minus 2, 6 minus 10 minus 4. A asterisk B, A into B is equal to this answer. One example here, I will show you what the method is there. A is equal to 1 2 3 4, B is equal to 2 4 6 8. Suppose these two matrices are here. A asterisk B, A into B, this is the first column, first row, and this is the first column, and summation of it 1 into 2, 2 into 6, and summation of first row, first column, first row, second column, second row, first column, second row, second column, and we will get the answer. Okay, now we can also use A dot asterisk B. Before the asterisk sign, we will use the dot for the method element by element multiplication and enter. We will get the answer. A dot asterisk B. Here you can see 5 into 2 10, 4 into 8 32, 5 into 7 35, 6 into 10 60. Okay, this is the answer by element by element. Now A divided by B, we will get the answer is equal to this. The method of this A divided by B is equal to, we can write A asterisk B inverse, where B inverse is equal to 1 divided by mod B into adjoint of B. This is the adjoint of B and this is the mod B. B inverse, we will get the answer B inverse. A divided by B is equal to A into B inverse, and multiplication are there, and we will get the final answer 0.5, 0, 0.5. Similarly, A / B is equal to A inverse B. Okay, you can check it and calculate it. Okay, A / B. Let's check it. Here A is equal to 1, 2, 3, 4, 2, 4, 6, 8. Okay, A is equal to 1, 2, 3, 4, and B is equal to 2, 4, 6, 8. 2, 4, 6, 8, and divided A divided by B. We will get the answer 0.5, 0, 0.5. You can see the answer 0.5, 0, 0.5. Okay, you can use these also for the inverse division. How we can express three-dimensional array? I will show you the 3D shape. This is the two-dimensional matrix first slide. Okay, these are the elements 1, 2, 3, 4. This is the first slide. 5, 6, 7, 8. This is the second slide. These elements from the second slide, and so on, 3, 4th. Okay, you can add more slides there. For that, A of colon, comma, colon, comma, 1 of is equal to, this is for the slide number, this is slide number 1, and its elements are 1, 2, 3, 4. For the second slide, we can use number 2, 2, 2, 6, any matrix. Okay, one slide, second slide, you can add more slides. Okay, this is the 3D array. So this is 3D array. Now I stop here. Almost we have covered the all basic helpful things. I hope this video has been helpful for you. Thank you so much for watching. Take care.